In our notes today, we're going to learn how to graph from 3 points when our equation is in standard form. Remember, this is the standard form of the equation, and this is the quadratic that we are going to be graphing. Our first step is to find the x value of the vertex, which we find using negative b over 2a. My b value is negative 4. And I'm going to put another negative outside because of the negative in the equation. Over 2 times a, our a value is 1, and this gives us positive 4 over 2, or x equals 2. So that is 1 point. To find the y value, we're going to plug 2 back into our original equation. So we have y equals 2 squared minus 4 times 2 plus 1. 2 squared is 4, 4 times 2 is 8, plus 1. 4 take away 8 is negative 4. Negative 4 plus 1 is negative 3. So the coordinates for our vertex are 2 and negative 3. Our axis of symmetry is going to be x equals 2. It is always the x value. And our y-intercept, we learned this in our investigation and we talked about this in previous notes. The y-intercept in standard form is always our c value, our constant. Therefore, 1 is going to be our y-intercept. As a coordinate, that would be 0, 1. So we're going to graph these 2 points, the vertex and our y-intercept and our axis of symmetry. Then we're going to do the last point, which is to reflect the y-intercept to get our third point. So on our graph, we are going to go right 2, down 3. I'm going to go ahead and draw my axis of symmetry right now, which is always the vertical line that cuts the graph in half. I'm now going to graph my y-intercept, which we said was 1. And for the last step, I'm going to reflect my y-intercept across my axis of symmetry. So because it is 2 to the left of my axis of symmetry, I'm going to go 2 to the right in order to reflect my y-intercept. I now have the 3 points I want. I'm going to go ahead and record 4, 1 as my coordinate for my reflection of the y-intercept. I'm going to connect my points, and we have graphed our parabola.